Okay, one thing is I would like you to obtain a new periodic table and mark it up just like what I have here. These are the orbitals that we mentioned before about S, P, D, and F. And one of the first things I want you to notice about this is if we look at the P block, so I'm sorry, S block. If we look at the S block, and helium belongs over here as well, I have two blocks. Now, count your P, which is this block over here. 1, 2, 3, 4, 5, 6. You're going to find another even number. Then when I go to the D and I count across, you're going to find 10. And then when we do the F block and we count across, we find 14. And so there's a reason why it's evenly spaced and why it's always even numbers. So again, I want you to color up your periodic table so that you have this as a reference. A few other takeaways we'll talk about later. For right now, we're just getting the fact that we get S, P, D, and F. We get even numbers. And so what we're about to learn is what's called electron configuration, and it's just another way to identify an element. So I can identify them by its atomic structure, the first one's neutrons, electrons. I can identify them through spectroscopy, and I can identify them through electron configuration. Now, there are some guiding principles that guide us through this, and the three principles are the Aufbau principles, which is going to tell us that we always start at the lowest energy level. What it means is you always start at hydrogen. It's like playing a board game. You always start at the starting point. That's hydrogen. Pauli's exclusion principle basically tells us that when I have it marked up, I have it marked down. So we're treating the electrons as being like Earth, okay? And just like the Earth rotates on its axis, so does your electrons. And just as we see in magnetism, where north is attracted to south, we treat it the same way with the electrons, that we have an upspin attracted to a downspin. So opposites attract. And that attraction lowers the energy, overall energy. And then we have Hund's rule, which we'll see when we get this feeling. And it just tells us we got to put an electron in every single room before we can double book the room. So if you think about this like being like a hotel room, okay? We're trying to book out our hotel, and we're going to make sure that we have one in every room before we double book a room. So let's look see what this is like. So I've included this periodic table here just for reference, and I have this diagram that's multicolored that you're going to see is going to correspond to something. So here I have, let's do fluorine, and fluorine is right here. And I know that this periodic table does have your ending electron configuration on it. Again, it's a guide for you. So sometimes it helps if we look at our endpoint, okay? So let's look. If I look across, fluorine is on row 2, okay? Fluorine is in the P block, because that's what this color means. Okay, so it's in the P block. And I'm 1, 2, 3, 4, 5 blocks in. So this is my ending point, okay? So how do I feel this? As I mentioned before, sometimes it's easier for y'all to look at your endpoint. So we mentioned that fluorine is 2p5. So here's my 2p. I'm going to put 5 arrows in here, and this is where I'm going to show you, this is Hund's rule. So I'm going to put an up, up, up. I have filled each one of the blocks with an up arrow. Now that I have one in each, now I can go back and fill it with the extras, because I need to have 5 arrows represented in this 2p block. So down, down. Whoops, I don't need that one because I only need 5. So we count there's 5 electrons. Now, we're not done yet. That's just the endpoint because sometimes that helps y'all to see the endpoint. So now we need to, there was Hund's rule, and then when I doubled them, that was Pauli's. Now the last rule you'll see is Aufbau. Aufbau in German means to build up. So now I'm going to go back to my starting point, 1s. There's an up, there's a down. There's an up, there's a down. Now, why was I able to do that? Because the only way that I can get to fluorine is I have to start here at hydrogen. That's my starting point. And it's just like a game. I start here, and I'm going to move my piece to helium. Still not there. So now I'm going to slide down to row 2. 1, 2, still not there. 3, 4, 5, 6, 7. And I'm now there. So, another way of looking at this, checking wise, is whatever my atomic number is, this is 9. Okay, so the atomic number is 9. Then I need to have 9 arrows here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we have 9 arrows. Then I've done the configuration properly. Now how do I write this? I start with 1 and I write 1 S2, 2 S2, 2 P5. And that's how I write my configuration. That's my answer. Okay. On the next one, we'll be practicing some of this.